Hello there, my name's Vince from My Mate Vince, and in this video today we're going to be trying to fix up this Tower 9 litre dual air fryer. So basically you can have different temperatures on the left hand side and the right hand side, so it's kind of like two air fryers in one. I bought it from eBay, 40 of course, and I got it for 50 UK pounds. They retail for just over 100 UK pounds, about 110, 120. So let's get it out of the box and see what's happening. It was listed as heats up but fans not working, and it said it was new and sealed, so it might be interesting. I love it when something is new and faulty from the manufacturer. So let's take it out and see what is happening. Right, the inside baskets do look very, very clean, so I don't actually think it has had any use, but yet it does smell just a tiny bit of chip fat, so who knows. I don't think if it's had use, I don't think it's much. So yeah, I've just turned it on and it does heat up, but the fans are not working. So if you have a look here, if I was to do the left hand side, let's go to chicken there, press that one there, that should now be working, but listen, there's no fans. Yet if I leave it on for like 10-15 seconds and put my hand in here, I can feel just a little bit of warmth. And if I do the same on this side here, so let's go to that pizza and start. Again, I can hear it click like a relay clicks, but there's no fan whir. Yeah. And also I can feel a little bit of heat there. So yeah, the listing is completely correct. The fans are not working. Let's get it over to the map and see if we can work out why this fan's not working. Oh my, this thing is absolutely huge. Right, let's take out the drawers. I'm hoping that there's going to be numerous screws around the place. Yeah, I can see a residue of some sort of like grease or something in there. So yeah, it's definitely had some use. Now, obviously I am unplugged, of course. So the fans. Okay, I can see that there's two fans here. Oh yeah, this definitely has had use. Right, okay, I can see fans here. Said it was new and sealed. Now, that one feels a little bit... That's not quite as smooth as that one, but they are spinning freely. So we have screws here. So I need to get to the top half of this machine because it doesn't really look like there's much going on the bottom half. How do I get into it? Clearly there's not going to be, this is a modern product, there's not going to be any teardown videos on YouTube on this. So it's always hard when you're the first person trying to do something. I can hear something rattling around inside. Now, I wondered, do I take the bottom off and that might give me access to the screws underneath here that will then take the top off? Or does the top simply unclip? We're not going to know that until we have it apart. I think I better do the safe thing to begin with and just undo the screws at the bottom. But we might find out by the end of it that you just have to undo the top. Okay. I have switches down here, so this is how it knows, you see at the bottom here, this is how it knows when the tray has been inserted, I think. So how does it actually, does it force something down? Let me just get the tray, see what's happening. Yes it does, so have a look here. Can you see we've got this part of the tray? And it clicks it up there. Right, first things first, I just want to make sure that these are actually working. I think they are. But I suppose if they weren't, and I don't fully understand this machine, then maybe... You know what I mean? Maybe that would, it would turn on, but the fans wouldn't come on when this is undone. But you can clearly see that's working. Yeah. And let's go on to this one. Just do this with my finger. Oh, well, isn't that interesting? I wasn't expecting that. Right, okay, 1 second, let me get the tray. Ready? Oh, it is working. I mustn't have pressed it in enough. That wasn't working before. What's going on? Maybe I wasn't on it properly. So I don't think it's made any difference taking this off at the bottom. Yeah, even if I take off this bottom bit, the side is not going to come with this bottom bit, and the side is covering up screws in this compartment in here. So I'm not going to be, there's like hidden screws along the side here. So I don't think that's anything to do with anything. So let's attack it from the top. I'm thinking that this here probably unclips. Ah, maybe this middle section comes out. Oh, that might be it. That might be it. Here we go. Here we go. Oh, satisfying. Come on, one more. One more. Yes. Ta-da! Excellent. Clips here. These are all the clips going around the edge here. Brilliant. Easy when you know how. And now we've got screws down in here. Right, now, are you going to come off? Right, it wants to come off here, but not at the back. So does that mean there's more clips at the back? Or do we have to take these things out? I think you just lift this over it. Look, watch this. See here? So put a bit of pressure on the lid, go in here and lift it over it like that. There we go. So that kind of keeps it in place. We are it. Oh, what do I spy here? I wonder how that got there. A perfect chance to give a shout out to today's sponsor of the video. PCBWay is your one-stop solution for all things PCB fabrication and assembly. From rapid prototyping to full-scale production, PCBWay delivers top quality products. So whether you're a seasoned engineer or a hobbyist just starting out, PCBWay's user-friendly interface makes ordering your own custom PCBs very easy. And PCBWay do a variety of different services, including but not limited to assembling your PCBs, CNC machining, 3D printing, sheet metal fabrication, and injection moulding. So when you're ready to take your designs to the next level, look no further than PCBWay and bring your ideas to life. So as always, a massive thank you to PCBWay for sponsoring the MyMateVince channel. Now let's get back to the fix. It's really helpful when sellers do that for me. Now let's undo this top thing here. So this is to do the control. No, the whole control panel is just fed from 3 wires. What? I thought there'd be a ribbon cable going up to it. Okay. Let's, I'm going to break that. There we go. We're out. So I'll put this down to one side. Clearly the control panel is working fine. I'm amazed that everything's run off 3 wires. I'm not sure if I've ever seen that before. Or does it just need to... I suppose if this has all the brains in here, that just needs power, and then it just needs to send... No, because the thing is, it's got to feed the relays. I would have thought that there would have been more than 3 wires there. What have we got? We have got earthed here, earthed here, earthed here, earthed here. That's earthed. Now, where... So we got 1 is going to here, and 1's going to here. And then this is going to where? Is this going down? It's going into that one, which is connected up onto this big one here. And this is going into this one, which is connected to there. And then we're going down to the switches at the bottom. So they go to the switches at the bottom. Okay, well we know the switches are working okay. So why are you not working? Clearly there's something on the board. So I think we need to take the board out and see where these 2 things go. Let me take some pictures. taking pictures everywhere because it's amazing how you'll forget when you start pulling out the leads. Just wondering if I can turn this around. I'm going to have to snip that. We have a little chip here. Big chip here as well. Well, I can't see anything that looks burnt. Can't see anything that looks burnt. So I can see what looks like a little fuse here. 3.15 amp. Let's see if that's intact. It must be jumping here. So meter in continuity. Yeah, that's all right. That's okay, which I suppose it would have to be, wouldn't it? Because let's think about it. It's feeding the front board. So it's not going to be anything to do with like the mains coming into it, or even the step down to lower voltage. Oh, so look, it goes to... hold on now. The motor is also fed, is also feeding. It's the same thing feeding the element. And the element's heating up. So why on earth? That says to me that both motors have failed then. Because both elements are heating up, aren't they? Yeah. Fan and heat. Are they the same? Are they on the same track? Let's have a look here. Are these on the same track or not? No, they're not. That goes via the relay. So what does this go via? Oh, could it be these little transistors then? Two little transistors here. It's odd that they both failed. I've got to find something which is in common with both of them. So they go to the transistors, and then they go down to that part of the relay and that part of that relay. The relays, I can hear the relays working. And again, if one had failed, surely one side would still work. Right, we need to check the windings just in case both motors have failed for some weird reason. So I'm going to go there and here, and that should then check it. Let's see if I can undo this. Okay. Right, let's go to ohms. And we'll go here. And this wire nut, so that's going to be 1. And the wire nut here. No way. We haven't got anything. No way. That's really odd. Okay, let's do this one. There, and that goes off to this one here. There and here. No, that's impossible. How can both motors be faulty? That's really, really, really odd. Really odd. Okay, I think what we're going to have to do is try to undo the... I don't really want to undo the wire nuts. I suppose I could use Wagos instead though. Right, let's look at one of the motors. It's interesting. Just don't understand how both motors would go. Really, really bizarre. There is something weird here. I wonder, is there some kind of thermal fuse? Those screws don't want to come out. Annoyingly, I can't even really get to. I can't really get to this. Even if I take this out, this is all wound round this core on the inside, isn't it? I think I'm going to cut this sort of Kapton tape stuff and see if I can get to here. Got to be very careful not to damage the cable on the inside. Unless it was faulty from manufacture. The thing is that it does smell a bit off food. The whole thing is bizarre because I just can't see how these would have just both failed. Really, really odd. I mean, surely I have to measure a coil. That's how it works, isn't it? Right now. Ah, okay. So we are soldered on. You can see the enamelled wire there. That's one end of the enamelled wire. And this is the other end here. So between here and here, we should have an ohm reading. If we don't, it means, 1 second now. Yeah, that's that side there. So what is this thing? Is that a temperature thing? AUPO. Do you reckon that's some sort of thermal fuse? Nothing on that side. There's some stuff written on the top. And then we got that there. It definitely says 130 degrees, doesn't it? I bet that's some sort of thermal fuse. And it's probably glued just here. You see where the... it's probably glued just like that. Down on there. We did have a sleeve on it though. Right, okay. Anyway, enamel. Who cares about the fuse? The enamel goes to this side. Ah, then it goes to there. It's going to be a thermal fuse. It's overheated. So, I bet if we go on the enamel, we're going to have a reading. But we're not going to have a reading through the fuse. Ah, this is really interesting. So watch this. If I go straight onto the enamel, here and here, there we go, look. 151 ohms. But yet, this wire here goes off to this side of this fuse. So if I was to take this off and go between here and here, we're not going to have anything. I bet you we're not going to have anything. Open. Oh no, we're in the meg ohms. That's probably my fingers. Hold on 1 second now. And also this is crimped on this side, but it's soldered on this side. Could it be the fact that it was soldered on at the manufacturer that it broke? Because look, why have we got to crimp that? This is really, really interesting. Why have we got to crimp that side and solder this side? I appreciate it's enamelled cable and you probably have to add heat. I know you have to add heat to it to melt the thing off, but why would it be crimped here but soldered here? Wouldn't that cause the fuse to blow? Because if it was only 130 degrees Celsius, to solder that, you're going to have it 230-ish, or whatever low melt would, whatever lead-free would melt at. Well, there we go. That there is our problem. So what happens is, it can't get from here. If I put it to continuity, yeah, it will get from the wire nuts here to this here, the crimp, yeah. See, it's going to the crimp, but when it goes through that fuse there, it's not coming to here, so it can't power. It can't power this enamelled thing here. So let's take apart this side here. I think the same thing's happened on this side. Really, really odd. Really odd. And if it's faulty on this one, I bet you it's 40 on loads of others as well. Just going to have a quick look at this one. Oh, it's 150 degrees Celsius, 2 amp, 250 volt. Let me zoom in. This hasn't got a sticky mess on it. Maybe I can just buy these then. There you go. How clear is that? So I'm going to type in AUPO A8-F. Jet, I've seen that before, PES. Maybe they're just standards. 150 degrees Celsius, 2 amp, 250 volts. Interesting. Well, I wasn't expecting to find one of them here on the motor. So let's take this off here. So if I go across here and here, there's nothing there. And if I go across the red wire, go into here, so the wire nut to the crimp, you can hear I've got something, but then I haven't got it through here. Yeah, and if I go to ohms, let's see if we have 150 ohms on the actual wire. So let's get this one out. There we go. So between here, be careful that I don't damage the enamel, here and here, give us a reading. There you go, 153 that you can't see, 153. It's the same as the other side, but yet when we go on ohms across the thermal fuse, nothing. Brilliant. Oh, really, really enjoyed that. Yes. So luckily for me, they are readily available. So I'm going to order some up. I'm going to order 4, even though I only need 2, and it will just allow room for error, because when I solder these in, I might end up burning another one out. It happened to me in a coffee machine years ago. But what I can do is I can like sellotape pound coins onto the thermal fuse to keep them cool while I'm doing the solder, or I can use pliers or something, basically clamp it with some sort of metal to keep the thermal fuse cool. So when we solder it, obviously we're soldering at higher temperatures than 150 degrees Celsius, but it should be fine as long as we do clamp some sort of metal onto it. Clearly, if I had clamps, I would use that on the wires, but just like the manufacturer here, the reason they haven't used it on the enameled wire is because they've clamped the side which has a normal wire. A wire is conductive, so it's fine to clamp straight on because it's conductive throughout the whole thing. But with the enameled wire, the middle bit's conductive, but the enamel on the outside is a coating so it doesn't conduct, you know, so you can wind it next to each other and it doesn't short next to each other. So if they had just clamped the thermal fuse onto the enameled wire, there's a good chance that the clamp wouldn't have bitten through onto the actual wire inside the enameled wire. So hence the reason they soldered it on, because when you add solder, you melt the enamel off. The heat of the solder melts the enamel off, and then you conduct to the actual wire on the inside. So basically, the manufacturers are quite happy to solder one side. I'm going to be soldering 2 sides. So next time you see this video, you will see that the 4 fuses have arrived, and we can solder them in place and see if this thing starts working again. Right, it's about a week later now, and my 4 items have arrived here. Annoyingly, these ones are labelled up as like A8-F, and then it says 2 amp at the bottom. These ones are A8F, but it does say 3 amps. But what I'm thinking is, it's a thermal fuse. So I'm thinking that's okay, because it's to do with heat, isn't it? So even if these were, if you were to replace them with 10 amp, is it still okay as long as the fuse, the thermal rating is the same? So if you could put that down in the comment section below. These are both 150 degrees. So I'm thinking it doesn't actually matter what the amp rating is. As long as the amp rating is enough, it's okay to go higher, but not lower. That's what I'm thinking, but I could be completely wrong. Right now, as far as I know, polarity doesn't matter, but I'm going to keep them the same anyway, with the label side up this way. And these have little heat shrinks on the leg, or they were made like that. So I'm just putting on the same length little heat shrinks here. And I'm just going to see if it will melt down with 100 degrees Celsius. I don't want to go any higher. I'm not sure what the heat shrinks will melt down at. And look, I'm just going to use this here as a way of kind of trying to get the heat away from the actual thermal fuse. I just want to see if 100 degrees will melt this down. I'm doing it on this end of it because I don't want to... risk damaging the fuse. No, I don't think 100 is enough to melt that down. Okay, well I don't want to go any higher. Let me just see if my soldering iron, if I was to just to rub that across here. Yeah, that's melting it. There we go. It's only the end ones that I need done. Okay, let's solder them in place. So if I had little clamps, I would clamp it on, but this one's been soldered here anyway. There we go. That's off. So I'm going to cut these down to the same length as the others. Right, let's flood that with solder and try to be as quick as possible. So I'll wait until my iron gets up to temperature. Let's put a little bit of flux on just to maybe help it a little bit. Here we go. Right, I don't want to be long at all, so I'm going to put solder all over my iron, and now I'm going for it. There we go. That's on. I'm just going to do one more up higher. There we go. I'm pretty sure that will not have blown it. Let's have a quick check. I'll be gutted if it has. No, that's still fine. Let's add a bit of flux on that. And same again, iron up to temperature. and I've got loads of solder on my iron. Here goes. There we go. Excellent. Right, so what I'm going to do is I'm just going to look back at the video and I want to see, actually I took pictures, I want to see how this was connected up. Right, okay, so they've got a sleeve on. Just shows the importance of taking photos, especially when you have to wait for spares. You think you would remember something, but you just don't. You know, you're not going to, well, I suppose some people will, but I certainly don't anyway. But then when you see it in front of you, it's just so easy to copy what was there beforehand. So, yeah, I took plenty of pictures, so I'm just copying that. Basically, a sleeve goes over the thermal fuse, and there's another little heat-resistant sleeve that goes over one of the legs of the thermal fuse, and another one on the other leg, and then I just need to Kapton tape it all back together, making sure the thermal fuse is pressed down against a coil, you know, the motor coil, and by the end it looks pretty much identical to how it did before I took it apart. Well, there we go, that looks pretty good, I think. So I'm very happy with how that's turned out. You can see they're all insulated there, they all fit in there nicely, and we have the thermal fuse on the top just like it was before. So if you have a look here, that's what it was before, and this is what it is now. It looks pretty good. Right, I'm going to do exactly the same over this side, and then I'll start filming again when that side's done. Right, there we have it. That one there and that one there with Kapton tape pushing that thermal fuse against the coil. So the only thing I need to know is, because I'm pretty sure this is going to be working, is am I alright with a 3 amp fuse in there rather than a 2 amp one? Because I know normally you shouldn't put more in, but these are thermal fuses. So will it be okay, because it's still going to cut off when it reaches that temperature? So if not, clearly I'm going to have to take it apart again and do and put the 2 amps in. I can't have a safety device in here which isn't acting as a safety device. Now let's put this where you can see it. Just rest it against my belly. So if I was to go between the board here, and it should be this one all the way down in here. Can I get into that wire nut? Right, so 150 ohms on this one here, the left hand one. Now let's go here, the right hand one, and it should be this one down here. Let's try to jab that in. So this should also be 150 ohms. Come on. Result 148. Fantastic. So we are now measuring the windings, while before we weren't. Right, so I'm just going to cable tie them up there. That's there, and I think then we're ready to put this back together. So that's not under strain there. That's give that a bit of slack there, and that goes to here. That's not under strain. Perfect. Still confused why it failed in the first place though. And again, you can see the product hasn't had much, if any, use. Just like the bread maker I did all those Christmases ago. That had no use, but that had drop damage. Right, okay, that's that. I think we can put this back together. So we're nearly there now, just popping back on the lid and putting in the final screws. While we're doing that, we'll give a shout out to the My Mate Vince Massive. The members this month are kitsdigital.com, Kip Hakes, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJ VG, Pixie, Anthony Dean, Bazza2, Russ Melanson, Gaspar Heller, Rickard Berglund, SoulReaver555, the My Mate Vince fan club over on Facebook, Astral Red Panda, and last but certainly not least, Shamsa Al Sawadi. So massive thanks to each and every one of you. Now let's pop the lid back down and see if these fans start whirring. Right, I'm not sure which way this goes on. Is it universal? Not sure. It seems to fit nicely though. So click in. Excellent. Right, let's put it on the kitchen floor and let's see if the fans are now spinning. Right, here goes. I haven't turned it on yet. I've got the safety switch here just in case it does go bang. We're plugged in. Okay. I've already forgotten how to use the thing. Right, so let's just do chips. 1, chips. Let's overload the thing. Let's do something on this side as well. 2, whatever that is. And let's go. So play. The fans are working. Yeah. Right, let's just see if it's going to start heating up. No heat yet. I'll give it another minute or so. So, clearly these two things were faulty, and these are thermal fuses for safety. So what happened to this for this to go here? The only thing I can think of is drop damage when it was on. But I can't see any damage around the place, but who knows how it fell. Maybe if somebody tripped over something, the whole lead might have come and it might have just went crashing down onto the floor on the bottom. But I don't know why these would fail on a product that looks brand new. What would cause that? Same thing happened with the bread maker years ago. The only thing I could think of is what people said in the comments section was drop damage can cause these to blow when they're on. But if you could confirm that, that would be useful, because then it would make sense why this might have failed. Because for both of them to fail, I think is really, really odd. Right, I can feel heat now starting to come out the back here. Yeah, and there's heat in both baskets. Right, I am going to turn this off, give it a clean up, put it on the counter, and I'm going to cook something and finish up the video. Just a couple of minutes left of the burning off, but this is really interesting. I never noticed this before. On the back of McCain's chips, it now has in an air fryer. So it was always like gas hob and electric oven, but now we've got air fryer as well. And look at this, got these Marks and Spencer's chicken goujons. Again, it's labelled as air fryer. And if you look at a fan oven, 200 degrees for 15 minutes, air fryer 180 degrees for only 8 minutes. That's nearly half the time. Absolutely crazy. And look, from frozen, 10 minutes and 20 minutes, so it is half the time. Absolutely crazy. I can't believe it cooks so quick. We haven't really got used to air fryers in my house yet. We've got this one here that I fixed up, and my kids use it for chips and fish fingers, and that's about the only time it gets used. But maybe if this is a bit bigger, maybe it could be a potential to be used. The problem I've got is it's just taken up the whole kitchen. Look at the size of the thing. It's absolutely massive. I think it's going to be too big for my kitchen. Oh, we're done. Looking good. And looking good. I think I might put those on just a little bit longer. And I think I might put those on a bit longer as well. I like things crispy. Let's do a goujon. That's raw! Joke. Well, there we have it, beige delight with the must-have brown sauce. But for the healthy Vince, I'm drinking apple cider vinegar with the mother. So, yeah, it tastes absolutely fine. To me, it doesn't taste that much different than oven food. But it certainly is a lot quicker. So I suppose if you're watching the pennies, then it probably would be better to be cooking this way, because it takes half the time, doesn't it? And there's no preheat time. So I can see why they're so popular, especially if you were maybe living on your own, like a student or something. Why do you want to be heating up a massive oven when you can just heat up something that's, you know, so big? And this tower one here, it is useful that you've got two different sides with two different settings, because you can throw something in later on without disturbing the food that's being cooked, or you can just cook two different things at two different temperatures. So it is it's quite a clever idea. I can see why people would go for it. So yeah, I mucked up massively getting the wrong thermal fuse. I will get the correct ones. I'll install them off camera. You see the process in the video is the same thing. That's why I say don't copy me when you watch my videos, because clearly I make many mistakes. But by me making a mistake, you now know not to make that mistake, or at least we all learn. You can read down in the comment section and see what people say, and they might be like, Vince, you don't need to worry. It's all about the degree the 150 degrees that it will burn out at. Or other people might say, yeah, it's massively important. So you see, we all learn. Why, if I just put in the right one to begin with, then you're not actually going to learn anything about those thermal fuses apart from the fact that they broke on this one. So that's it. I'm going to eat my chips and goujons. I will bid you farewell, and I see you all again very soon. Thanks for watching.